manager, all inside the industry itself, and then joined CAI about 3 years ago. Since being at CAI, I'm a contributor for ISPE's Good Practice Guide on Asset Management and Maintenance. And I have a bachelor's degree in bioprocessing and biomanufacturing from North Carolina State University. My primary focuses, or where I tend to spend most of my time, is in both the early asset management phase. We're going to talk a lot about that today. How do we make sure that we set up in a very short amount of time during a CapEx phase a successful asset that can last you 20, 30, 40 years as you're going through it, as you're using it. And then the other side is digital asset management. Some folks will call this Industry 4.0, Pharma 4.0, but how do we convert all of our physical assets to digital so that we can manage those effectively? If they're in a digital space, they can talk cross-functionally, and we can find out all kinds of fun answers about them. So that's kind of a more or less a play space for me on the side. So that's intros on myself. Before we get into talking about why OEM maintenance recommendations don't work, real quick, we'll talk about why they do. And I promise it's not a trick. So they work because, number one, vendors or manufacturers do have the expertise in their equipment. This presentation isn't designed to sit here and convince you that equipment manufacturers don't know what they're doing, right? They certainly do. They're experts in their equipment. Number two, they work because we need them to, right? Project timelines today are much, much shorter than they've ever been. And in this compressed timeline, we've got to be able to deliver quickly. So we leverage vendors, we leverage manufacturers very, very hard. So these are reasons why they work. Reasons why they don't. You'll see the OEM maintenance recommendations over here to your left-hand side. The reasons that they don't work really have everything to do with operational context. Okay, like we've said, the manufacturer is the expert in what they've built. The vendor is the expert in what they've sold you. Okay, but what they don't know is how you're going to use it. Your user requirements may be different than what they expected. Okay, and I don't necessarily mean from a URS, but how you use their equipment may be different than how they design their equipment. Especially today in cell and gene therapy, being one of those spaces where equipment that is normally kind of lab-based, benchtop equipment is now being used in manufacturing. So that comes with its own ramifications. Number two, operator training. Okay. How our operators interact with that equipment is different. Humans are huge sources of random failures. So it may not have been designed in that way. Operator A, operator B interact with the system very differently, or can interact with the system very differently, introducing their own errors. And then the third one is really around maintenance execution. Most of these vendors or manufacturers will sell you, a lot of them anyway, will sell you a maintenance contract. With that, good or bad, the maintenance contract is what it is. If you engage in the maintenance contract, though, sometimes, and especially because, one of the things that you're leveraging is their expertise. One of the things that you're leveraging is their expertise, right? So as they're out there doing their maintenance, they're seeing other things that maybe your maintenance technicians may not see. Okay, so if it's designed for purpose, if all of your operators are complete experts on the systems, if all of your maintainers are complete experts on the systems, maybe they do work. But in many cases, this is simply not the case. The other piece that I'll call your attention to when we talk about maintenance is this age versus random failure. The OEM maintenance recommendations or the manufacturer maintenance recommendations, a lot of times are geared towards age-related failures. You'll see a lot of pieces of replace this at this interval or lubricate this or do these on certain intervals. Those are all really geared at age-related. Those that are involved in human interaction, user requirements, anytime, really the operational context side, all of these really induce random failures. In several studies that have been done over the last 5 decades or so, the general rule of thumb is the 80-20. Only about 20% of all the failures that we see across our plants are age related, age or wear dependent. The other 80% are random in nature. A lot of them are human dependent. This, when I talk to a client, they're in firefighter mode. Yeah, we want to get in front of that, but we don't have the time. Most of the time we can point to these random failures not really being addressed because their maintenance program is really only addressing 20% of what's out there. So operational context is really the reason that a lot of these fall short of their expectations. So the remainder of this presentation is really going to be spent around, if that's the case, then what do we do about it? What we do when it comes to this is really around what strategy, what approach do we take, okay? Now, what you see here, I'm not a validation expert. I should be. I work for CAI. Commissioning qualification validation is a big part of what we do, but I'm not one of those guys. But this is a general outline of a lot of the validation and lifecycle documents that you're going to find, right? We have a site validation master plan. If we're doing a capital project, we got a validation project plan. That's going to tell us how we're going to do our activities within this specific project plan. We'll do system impact assessments. These impact assessments do a really good job of judging whether something is impact of product quality or no impact of product quality. We have all the various life cycle documentations around URSs and hardware design specs and functional specs and all these pieces that go with it. And then we've got the vendor's turnover package, right? Spare parts, operations and maintenance manuals, certifications, a whole slew of stuff in here. These all do a good job when it comes to how do we commission or how do we qualify a system. And it gets us a lot of the way there. A properly commissioned system is going to last a number of years longer in an error-free state than one that's not commissioned properly, okay? What it doesn't really tell us, though, are all these other pieces. What impacts my business? The system impact assessment talks about what impacts product quality, but how does it impact business continuity? Where in this does it tell us what should be maintained and what shouldn't be maintained? And I don't necessarily mean within a specific system, what elements do we maintain and what we don't, but for entire systems, should we maintain all of them? And then generally the answer to that should be no. We'll get into why in a minute. Should things be calibrated or not? Or what things should be calibrated? More specifically, what shouldn't be? These two questions around what should be maintained and what shouldn't really goes to a resource perspective. If we maintain everything all the time, right? We're not a maintenance company. We're a drug production company. If we maintain everything all the time, we're wasting a tremendous amount of resources. In addition to that, every time I go out and touch something, I run the risk of introducing some type of an error. And remember, that's 80% of our failures that we have out there. What should be calibrated, what shouldn't be calibrated? Again, that's a lot of resources that we're spending unnecessarily. What about reliability? Can we bake reliability into the early project phase? Yes, we can. And we'll go into how that gets done. How much information do I need? And how much is too much information a bad thing? Remember, every piece of data or information that you generate for a piece of equipment has to live with that piece of equipment for the rest of its life. That's part of the life cycle of the equipment. In a capital project, we're going to create hundreds of thousands of data points that we then have to maintain. If we create too little, we don't get the answers we want. If we create too many, we have created an overburdensome maintenance of that information. Eventually, we don't keep up so well. Some of it's not as accurate. And if anyone's worked with maintenance techs in the past, the first time I run across a piece of information that's not accurate, I distrust the entire system. So we want to make sure we don't run into that. What spares do I need? What should I do with them? Finally, how does all this information get into my system? If the answer to your capital project is I pay this guy to sit over and key in on keystrokes all day, one line item at a time. It's going to get really painful really quick. Can we do it differently? And can we make sure that we maintain its quality over that time? So a lot of times when I work with clients through HIS, we introduce what we call the asset readiness plan. The asset readiness plan lives at the same level as our validation project plan, but it answers all of these questions. It provides us a path as we go through this. Many of your sites will have processes for asset induction. You got to do these pieces as you go through. You're entering them into the system one at a time. And that's fine, right? And that's generally the way that it should be done. But when we're going through a capital project and we're introducing hundreds of different systems or hundreds or thousands of different pieces of equipment and spare parts and all this, that simply isn't reasonable. But we can create a plan that allows us to modify our rules as we're going forward to best support the business while not compromising the integrity of what it is we're doing. I'm going to stop there. I don't know if there's any questions in the room. I'm not sure even if we're supposed to do Q&A right now, but any questions so far? We're going to get into exactly what this readiness plan is.
Hey, Nick, I have one. Derek Pinto speaking. Earlier before you said that there was a lot of our failures were 80% related, or rather 80% of them were related to failure. I'm sorry, random failures, right? You said a lot of them are also human dependent. Do you know how many percentage is just random, like these things just break on their own? Or would that be more of an age wear attribute?
Good question. So as far as a breakdown of what of that 80% is human derived and what is just completely random and how it breaks down, the other area of focus when we talk about random is really manufacturing defect. Okay, so you get a piece of equipment, that transmitter has some manufacturing defect that's in it. It's really independent of time because it was introduced during the manufacturing process prior to getting to your site. A lot of systems that we have today that have been really well vetted have less and less of that, right? As they've reduced variability in their manufacturing process, they've kind of eliminated a lot of that. I will say that in my experience in working with clients, we have statistical methods that we can use to determine kind of what is age related versus what is random. And the vast majority of the random failures are human derived. And it just goes back to the old adage of if it ain't broke, don't fix it. Any other questions? That was a good one. Okay. Well, Nate, you're coming off mute there. I don't know if you had something, but I'm going to call that good. Okay. The asset readiness plan. We're going to take the asset readiness plan. I'm going to break it into two sections, and they're two equally important sections. The first one is our asset risk plan. Okay. Just like the system impact assessment that we did, just like the instrument criticality assessments we're going to do, the asset risk plan becomes to what depth and to what breadth do we tackle everything. The other side of this is our data migration plan. Okay. I've worked with a number of clients as we get into a CapEx project and it's, hey, I want to be able to do all this, but my IT group won't allow me to mass upload into our systems. I am here to tell you it's technically possible. It's a business rule or business decision not to do so. We can pretty much API into any system that we need to as we get through it. Where the concern comes in is when you're up, everybody's been in that catastrophe, or a lot of folks have been in that catastrophe of we're uploading millions of data points. And when we were done, we found stuff that was wrong. And it was because of the upload or it was because of lack of quality throughout the system. So they have a tendency not to do so. However, when I can come to the IT group or I come to the quality group and say, hey, we have a data migration plan, right? We know how we're going to ensure data integrity as we go through this, and we know how we're going to evaluate data accuracy. they have there's certainly a much more of a tendency to follow along with that. When is it most valuable to institute? Oh, thanks, Nate. As soon as possible. Typically when we come into this, and I'm actually going through this with a client right now, they're going to go into their IQs starting in June, and we're just now being brought to the table to figure out how to do an asset readiness plan. We're about 6 months behind. Generally, what I advise most clients of is around the time that you're doing your validation project plan, or shortly thereafter, is really when the asset readiness plan comes into play. There's a lot of stuff to put together. And if you do it correctly, and because when we get into what's involved in it, when you do this correctly, you're set up with a much, much better system as you go through it. So timing wise, I would put it close to the VPP. All right. Okay. My asset risk plan, my asset readiness plan is all going to get triggered off of one assessment, much like my system impact assessment. We're going to go through an asset criticality evaluation. So I have a note up here. Not all GMP systems have business continuity implications, but some non-GMP systems do. So many times I walk in and talk with clients and I say, hey, do you have a criticality assessment? Oh yeah, we've got that. Here's all of our GMP systems. Here's all of our non-GMP systems. That's great. And that from a product quality and from a compliance perspective, that's exactly what most folks are looking for. What I'm looking for is, do you have a prioritized list of those systems that impact business continuity? I can tell you that many folks don't have their electrical systems as a direct impact system, as a GMP direct impact system on their list. But if they lost their electrical grid tomorrow, they wouldn't be able to produce product. So it becomes a significant business continuity issue. That's why we go through this process. Now, the asset criticality evaluation that I'm showing up here is one that we have a base that we start with, and then we kind of start tailoring from there. But a lot of the concepts are still the same. We want to evaluate a system of a system of categories across the board: safety, quality, compliance. So the GMP or direct impact pieces go into this at that part of the calculation. How much does it cost to maintain and operate? What's its failure probability? How much do we need this thing to work? Okay, what's its impact to our profit? These pieces help to tell us how deep we need to go into something. Now, when we're doing this early in the system and all I have is a list of equipment to work from and some process flow diagrams, the question is, are we going to get all of this right from the start? And the answer to that is probably not. And that's okay. Okay. The idea is to have it at least in a prioritized plan as we go forward, so that we can, we can modify this over time as we learn. As failure probability, we think it's less than 2 years. Man, it's happening every week, right? Obviously, that's going to increase its criticality. We'll do these evaluations over time. We've actually built these in with clients directly into their maintenance management systems, so that the system itself will calculate most of the information for you and can actually adjust your priorities as you go. But as we go through, you'll come out with some type of a ranking: 1, 3, 5, 1 to 10, 1 to a million. Doesn't really matter what your number scheme is. There are times we'll put in certain weighting factors. Maybe we'll weight quality and compliance heavier than the other ones. Those are all pieces that we determine prior to going into the exercise. And then we go asset by asset as we go down. A lot of times we go down by asset classes, right? So if you have biosafety cabinets, for example, and you've got 20 of them, they're all going to be evaluated at the same time. As you score across, you come up, you add it up. There's a base, this is a basic risk assessment as we go through it. While this may or may not seem like a lot of work, generally speaking, if we have the system list, especially if we have a URS and we can organize some workshops, this takes about a week to get through. which is not a whole lot of effort for the value that we get out of it. Any questions on the asset criticality evaluation? This risk assessment drives a lot of decisions that go forward. Okay. All right. Once we have these scored out, now this is on a 5 to 25 scale for this one in particular. Once these scores go out, we'll typically break these into tiers. Okay, and I for this example, I use tier 1, tier 2, tier 3, tier 4. 5 to 10 is a 1, 10 to 15 is a 2, 15 to 20 is a 3, 20 to 25 is a 4. It ebbs and flows depending on how many categories and scoring system that you use. But for our purposes, we're going to break these into various tiers. Now you'll see we have tier 1 being our lowest tier. We have tier 4 being our most critical tier that we have. But we're defining this actually in our asset readiness plan. We're defining our approach across how are we going to maintain it? What level are we going to deal with on master data? What's our spare strategy going to be? How are we going to do reliability? How are we going to prioritize all of this information? Okay. So this drives a lot of it. And then depending on which level you go to, we write out the asset project plan becomes, a 10-ish so page document that really kind of steps users through on how they're going to go through it. So tier 1, run to fail. I'm a big fan of this maintenance strategy. A lot of people aren't. As long as we plan for it, we're okay. When there are elements out there that cost you more to maintain, or there's a greater risk to human-induced failure to maintain than it is to purchase a new one, then you run to fail. And that's okay, right? You have a spare on the shelf ready to go. If I can take it off the benchtop, unplug it, plug a new one in, send this one out to do whatever they want to do to it, but I'm waiting for that failure to occur before I do anything. I'm not going to do anything proactively. When we get into that tier 1, our master data approach is really at the system level. Okay, bad example, but let's just assume our Wi-Fi system is a run to fail. It would never be the case, but we would just have a line item in the CMMS that says Wi-Fi system. And all of our work orders get written to Wi-Fi system. And that's okay because it's a low criticality system to us and we don't need all of that information as we go forward. Our spare strategy is we're going to have a backup of the system. Analytical balances for me are a great example of this. We're not going to do anything to maintain an analytical balance. We may calibrate it, but we're not going to maintain it. If for any reason the analytical balance fails, then I unplug it. I have another one completely ready to go. I plug that system in and we go forward. From a reliability strategy, we really talk about failure reporting in this. We're going to have generic KPIs. We're going to have generic failure codes as we go through. Tier 2, as we step in criticality, you're going to see we go deeper and deeper into the machine. Tier 2s, this is where we're just going to, sorry, let's step back for a second. Just for some numbers, and it does widely vary depending on your operation. But if you're a lot of benchtop as you're going through it, you're actually going to have a fairly high percentage, 20-ish% or so that could be run to fail. Okay. OEM recommendations still in the capital projects phase. These are still going to be a vast majority of the systems you're going to go through. We'll accept any and all OEM recommendations. Our master data approach, then we dig a little deeper into the system. We're going to have the overall system, and then we're going to have the major components of that system inside the CMMS. The idea is that's where we want to write work orders to, because that's where we want to track information back for reliability. What I mean by major subcomponents, as you're looking at a PNID, right? The boundary of the PNID is the system, and the major components, up at the top of the PNID for the most part are your major subcomponents. Spare strategy, we're going to go with what the OEM recommends. Reliability strategy, again, some generic KPIs. And then we're going to track both the system and the major subcomponents. I know at CAI, we have some user data around some generic failure codes that we use across the board that at least gets folks started, that they can kind of tailor after that. Tier 3 is PM optimization. A lot of times this doesn't come into play during the CapEx phase unless you're doing an expansion, right? We're taking line 1 and we're creating line 2, and a lot of it is similar. Well, we're gonna take a lot of the OEM recommendations from that information, plus leveraging lessons learned from like equipment in the past. We may go out there and say, hey, the OEM recommended every 6 months from this, but we know from experience we can get 12. We're good to go. Everything else about PM optimization is kind of the same. Tier 4 is when we get into really the deep dive. Some clients get in the trap of everything is critical. And if everything is critical, nothing is critical. You should never have more than 2 or 3% of all of your systems in a tier 4 type level. If you do, then we're being way too conservative with our risk assessment. Because what we're going to do is we're going to do a deep dive FMEA, or failure modes and effects analysis, as we go through it. I'm going to crawl through every component on that system because it has such a high impact on my business continuity. I need to do that deep dive. Master data approach is I'm going to go after every single subcomponent on there that I can. Every valve is going to be in my system that I can write a work order to. Our spare strategy is going to be based completely off of our FMEA as we go. We'll make sure that the OEM is incorporated in that. But because of the severity of the failure, we're going to go after it through this deeper dive. And then from a reliability strategy, we have custom detailed KPIs that go after this system. And the way at CAI, the way that we've developed our FMEA strategy and our application that goes through this, one of the outputs of the exercise are custom defined failure codes for you to use going forward as you're using these systems. So you could see at our lowest criticality, it's just get it in the system. Data's the data's accurate, but we're not really going to do much with it. And then the further we go down, if you try to go OEM recommendations across the entire page, you will drive yourself crazy during the CapEx phase. You'll get up against the wall at the end, and you'll kind of force it through the door to finish the project, which, again, if it's properly commissioned, it'll last a while in an error-free zone, but eventually it comes home to roost, and you'll pay that price in 3 or 4 years. Any question on asset induction flow? We're going to get into data migration for a few minutes next. No? All right. All right, data migration. This is the one, like I said, like I mentioned before, this one gets tricky. Some IT groups don't want to give you the API into their system so that you can mass upload into it. Some CMMS systems, you can't even do that as a site through your IT. You have to go back through your vendor to be able to do it. Those get really frustrating. You can do it. There are ways to do this, but data coming in a lot of times is going to come in one of 3 ways. We're either going to field capture the information. This happens a lot in brownfield or existing sites. We need to go out actually in the field and capture all of the information that we go do that. At CAI, we actually use an application to do that, where we go out with a camera or a tablet and we can snap a picture of the nameplate information. We have an OCR tech that pulls the text out of the picture and starts to populate a database that we can then bring into the CMMS. Turnover packages, these are Excel files, these are flat PDF files. This is kind of the normal way of doing business as we go through it. And then the final way is through submittals from subcontractors as through the CapEx project. And we're getting more, I'm seeing this happen more and more in the industry. I'm actually getting quite excited about it as we get through it, because it's a lot more fun to work with. This is where we're using your BIM model. So you have a design build firm that's using a 3D architectural model to build your facility. If we're brought in early enough, right, as they're going through and defining what fields are going to do, we can actually manipulate or backfeed fields and information back into the BIM, that when your contractors, your subcontractors are actually putting all of that information in for you, in addition to handing you the turnover package. Now I don't have to convert all those flat files into fields. It's already in a database structure. That BIM model then becomes really, really useful to me while I'm in the operations phase if I upkeep the information. Okay, but during the CapEx phase, when it's time to roll it into the database, it's a pretty seamless integration to tap or typically do it through what we call a Kobe sheet, but we'll tap the BIM model directly into the CMMS, and it's one of the most seamless ways we've seen it do it, and it really does, because you're going to the experts to put the information in. It reduces the number of times you have to touch data. Every time you touch data, you have an opportunity to cause an error, and it puts the onus back on the experts. And our experiences, they do a pretty good job. But regardless, it's going to come in one of three phases. We're going to recommend the mass upload. Okay. But we're going to do 3 checks as we go through. And these are all defined. These are all quality approved, the validation quality approved as we go through. Our first one's going to be a statistical check. We're going to make sure that our field map confirmation happened. Okay. For some reason, column A didn't go into the field it wasn't supposed to. So we're going to do that check, but we're also going to do a statistically relevant check of non-impact system data accuracy. Sometimes this doesn't get checked through commissioning and qualification, or maybe not to the level that we're looking for it to go through. So we're at least going to go through on a statistically relevant check to kind of have a gut feel on how we're doing there. Our next check for a lot of our impact systems is really through our commissioning and qualification process, right? Those are our agents out there field walking down, verifying CMMS information against what's actually out there in the field as part of an IQ or IV test. That's our second check. Our third check and our quality approval is the QA summary report as we go through it. And while these checks sound simple, I've run across a number of clients that are using these asset induction forms. So you want to bring in a new piece of equipment, they give you a form, you fill out the information, engineering has to approve it, then validation has to approve it, and then quality has to approve it. And you have to actually do one form for every single system that's out there. And it's a really good way to waste a lot of time and ruin your day. So a lot of times with those clients, if we put in, hey, this is the process we're going to take to make this happen, we have a much stronger chance of being able to operate in that model. Any questions here before we do a wrap up? And I ask you just to do a couple things for me if you didn't listen to anything else I had to say today.
Yeah, just that one question from Nathan in the chat. That's it.
Yep, I got that one.
Yep, so we're good.
All right. All right, so assuming the last slide is really built around, these are the things that I see that clients don't get right in the beginning. And when they don't get these things right in the beginning, regardless whether you follow the asset readiness plan type setup or anything that we've talked about so far, get these 4 things right as we go forward and have these conversations in your organization. And the first one is, and we're going to go from bottom to top. And the first one is define what failure means. Jeff, let me get back to you on that one, on the field capture work. As soon as we're done here, I'll jump back to it. define what failure means to your site. You're going to write an awful lot of work orders in your CMMS. When I'm looking at it from a reliability standpoint, or when you come to me in a couple of years and say, hey, you know, some of our stuff's falling apart, can you help us determine this? I have to weed through an awful lot of work orders when we go through it. And if you can define what failure means to you, and not only what it means to maintenance, but, you know, top to bottom in your organization, understanding what is a failure, what is a breakdown, what is we can no longer operate because this thing happened, versus this thing over here is a nuisance. Because many times in your work order system, they look the same. So that's number one. Number two, do that asset criticality. Even if you don't use that to make any decisions during your CapEx phase, knowing your prioritization as you go through, when things do start to lift their head, you're going to have a prioritized list to be able to work from. The next one up, work orders to the lowest level you want to gather information. I work with a lot of clients who have nothing but their system levels out there that they write work orders to. Bioreactor A has had 400 work orders this year. Chrome Skid B has had 500 work orders this year. Chrome Skid must be, well, that's not true, but Chrome Skids must be worse than bioreactors. Or worse yet, we have a leak somewhere in building 2 because we write all of our work orders to the building. When you get to the maturity model where you're ready to get in to do the reliability aspect of it, it will require a Herculean effort to be able to do it. Creating slots in your maintenance management system at the right level. Again, I recommend taking the asset criticality side of it, but being able to write to that lowest level, having a place to write a work order to becomes important, because now I can look at all valves across the plant, or all 2-inch ITT valves across the plant. I'm not just looking at this bioreactor that may have an issue. And finally is the failure reporting. And this one, most people, when they go out looking for a CMMS, and I work with a lot of clients to try to figure out what path they're going to take on a maintenance management system, they look at it and they say, oh, well, I want a place that I can put my assets in the system, and I want to be able to write work orders. And they forget that one of the biggest requirements of a maintenance management system, and to be perfectly frank, one of the biggest areas that a lot of these systems miss, is it's one of the only places to capture failure information while you're in the field, and not just work order notes. We do it a lot of times through failure codes. Understand that aspect of a CMMS, and really, if you're in the selection process of a CMMS, really hold that vendor's feet to the fire on this. This is stuff that a lot of people don't think of when they're initiating the project, but man, it really does. It comes back and bites later. So if you do these 4 things, even if we didn't go through and do all that stuff during the CapEx phase, when you call me in a couple of years and we need to kind of dig through some stuff, if we've got these things, we can answer 90% of the problems that are going to be out there. So that was the conclusion of the presentation. I know Jeff had a question in there. I want to make sure that we get to it. So how does the field capture work? Jeff, I assume you're talking about how does our field capture application work? And not how, right? Typically you send, right? You send an employee out to the field, they write the information down on a form, they bring it back, they put it into a spreadsheet, and then it somehow gets to the system.
Yeah, I guess that what I'm looking at, or what I'm curious about, is, as long as I've been involved with these CMMS systems, I've always dreamed of just going out there with a scanner and scanning the information from the asset, and that just populates the record.
Yep. So the good news is we do have that today, and it can be integrated directly to the CMMS. So the way that it works, we leverage an OCR, or optical character recognition software. I would say 5 years ago, that tech was not great. Today, it's getting much better. So the way that works is the application is on some mobile device, whether it be your phone or tablet or whatever you're going to use. You walk out to the equipment. Hopefully you can get to the nameplate, and they haven't somehow designed the system so that it's buried in the middle of nothing. But you go out, you take the picture of it. That information, you're telling it where you took that picture from, and then the optical character recognition technology is actually pulling the text out of the picture and into a database. Okay, it's not perfect because it still has to be touched by a human in that case, right? You're getting make, model, serial number, manufacturer, those types of stuff. So once it's back into the database, somebody looks at it quickly, that's back in the office somewhere. We do this a lot of times where I have field agents out there capturing information, and then somebody across the country can be looking at that to make heads or tails of the text that's coming through, and just make that's a quality check for us to make sure it's good, so that it can be loaded up into the system. If depending on the maintenance management system that you have, there are maintenance management systems out there that and we don't own any of these, out there, that if you put in a manufacturer and model number, and they have that manufacturer and model number anywhere else within their customers, or what they call their master data pool, it will go ahead and bring you all the information, cut sheets, and anything they have existing somewhere within their network of that system. But the field capture application itself is snapping a picture. It pulls the text out of there into a database, and then that information is at least in a digital format that can go forward from there. That answer your question, Jeff?
Yes, we basically collect everything in a spreadsheet, or somehow get the information collected and put it into a spreadsheet and then mass upload it. But
That's
as
painful.
as our projects get bigger, it'd be nice to be able to go out in the field and just scan things, or as they come in the back door, scan them, right?
100%. And so we have done this as part of a project where you're sending out still out in the field and scanning as you go through. And then it's an application that again, if we can integrate it, we do an API into the CMMS itself, you can have the application, you can license the application to use every day as stuff is coming in, scan it and build it into the system is pretty sweet. I still think the BEM model on the submittals is the cleanest and easiest if you're in a CapEx with a design build. But the field capture application is probably the next best thing to that. It's certainly easier than writing it in spreadsheets all the time.
So just really quickly go over the BIM model. What is that exactly?
So your design build firms, your architectural firms, they design your buildings in it's basically a CAD file, a 3D CAD model of your building. These firms are getting more and more sophisticated. They've gotten better and better over the years, so that this is actually how they're organizing all of their subcontractors today to do their submittals and their information that's coming in. Okay. What a lot of clients don't know is here's a perfect, near perfect digital representation of the entire facility that you have. Most clients won't get that from their construction management firm, their design build firm, and it just, it sits there unused. What we can do, and I'm trying to think, I don't have that with, but what we can do is, as they're going through and defining the information for their subcontractors that they want to come into this 3D model, we can help the design build firm and say, hey, look, we also need these, 140 fields filled out for whatever pieces that are coming in. We work a lot with DPR, we work a lot with CRB to make this happen, so that as subcontractors are making submittals and doing these builds, they're actually putting that information in for you. So now there's not even a need to send someone out to the field to scan it, because as it was submitted into your construction management firm, the information was digitally added to this 3D model.
Okay, that makes sense. So they're basically, it's part of your, I guess, your design, building design and architecture process.
Yep. Yep. And so that's one of the newer trends that are coming in. I'm working with another client on the East Coast. That this is not only how we're getting the information in, but in the future, they'll actually integrate, the model will be a working model. They'll integrate it with their MES system, with their BAS system, with their EMS. Well, there's a lot of alphabet soup there, but all of their systems get integrated with their BIM as well. And now I can walk through a digital model, right? A digital twin of my facility in virtual space and see everything as if it's running. It's a really kind of slick way that the industry is moving.
That's pretty cool. I'm hoping that our automation guy is paying attention to these trends too.
Right? I hope so too, because those are a lot. I mean, to me, they're professionally satisfying to work on. I love working on those projects. Any other questions out there? Good question, Jeff. Nope. Okay.
I guess not. All right, well, again, I apologize for the technical difficulties I had at the beginning. I don't know what was going on, but it seems like it's resolved now. But I would definitely like to thank Nick for coming on and teaching us a little bit about asset management reliability. And I definitely want to thank all of our participants today too. So if you have any questions about this type of event or the content that was included here, please let Melissa or I know so we can make sure to have future events like this moving forward. All right. Well, thanks again, Nick. I definitely appreciate it.
Nathan,
Thanks.
thanks for the opportunity.
Thank you, Nick. Great training.
Yep, thanks everyone.